All right. So we're going to talk about concurrency with Grain and Lunatic. I know it's 5 p.m. on a Friday at a conference, and I'm about to talk to you about Erlang, but everything's going to be all right. So first off, who am I? I am mostly just some dude, but beyond that, a director at Supportable Software Systems. We use Wasm in production at the edge, and I'm also the co-author of the Grain programming language. So what is Grain? It's a programming language that compiles directly to WebAssembly, so we do that via binarian. We don't use LLVM or anything like that. It's strongly typed, functional, focused on developer experience and productivity, and it's super high level. We aim to have the language make you as productive as about writing a Python or a Ruby. You know, we're not trying to be Rust. Rust is Rust. We're trying to be us over here. So in order to do a talk where I'm going to show you a bunch of Grain code, you're going to need a crash course on Grain. And so I want you to mind the fact that there's some v0.6 preview code that's going to be coming out pretty soon. So if you're familiar with Grain, you might be a little unfamiliar with some of the syntax and other things. But all right, crash course, let's go. What does Hello World look like? Every module in Grain starts with a module header. In this case, module main, and we're just saying Hello World with a simple print. Pretty basic, easy enough. Bindings, use the let keyword. You can have, hey, here's a number, here's Boolean, string, all that good stuff. Functions, we use arrow syntax for functions. This is what they look like. If you want to have a recursive function, you add the rec keyword, and there you go. You have a recursive function. Of course, we wouldn't be a functional programming language if we didn't have first-class functions. So here, we're mapping over a list. In this case, we're just taking each element, adding one to it. That's it. And this is also how you include libraries in Grain. Use the include statement. Data types. This is where things get a little real. So sort of like Rust, we have enums. They're very powerful. We'll talk about them a little bit more in a second. And of course, we have records, so that way you can have data of different types all together in one place. So that brings us to pattern matching. Every big boy language nowadays has to have pattern matching, and so we do, of course. So in this case, we have an enum with some toppings for pizzas and calzones. We have an item. It happens to be a calzone. It's got peppers in it. And in the case that our data matches, hey, I'm a calzone, I've got peppers, we print, these are half off this week. In any other topping, these are 10% off, and otherwise, we've got no current specials. So you can nest these, you can get pretty crazy with it, you can describe your programs in many different ways, and it's pretty awesome. What makes us a little bit different from other programming languages is we understand that people just want to write some damn code. We understand that you don't want to learn a whole new functional programming paradigm just to write code in Grain, so we allow you to do mutation. We have let mute, which says, hey, this variable is going to be mutable, and you can use that sort of just like any other language. So this makes some other functional programming people angry, but we think it provides a better experience for people just trying to get in and get something working. So that was your crash course in Grain. Congratulations, you are now a certified Grain developer with 10 years of experience. You can use me as a reference. That's awesome. So we're going to take it from here with Lunatic. So Lunatic is an Erlang-inspired runtime for WebAssembly. So it's pretty sweet. If you've never played with Erlang, I highly recommend that you do it. But it's all centered around processes, lightweight processes. So we spawn up a bunch of processes. If they die, we don't care. Spin more up, doesn't matter. They get scheduled super quick, it's super efficient, and it's awesome. What's neat about Grain is it's really easy to do this. It's not going to feel like a chore like it might if you were using some other language. So, of course, it supports Rust, C, assembly script, whatnot. But we're going to do it with Grain, and we're going to show that it's awesome. So, like I mentioned, it's processes all the way down. It's built for massive concurrency, so you can spin up as many of these things as you want, and you sort of just don't care about it. It's all just going to work. And it's pretty fault tolerant. So if your app breaks, that's OK. We don't care. We just keep going. Lots of people who use Erlang are like people like telecom providers. Why? Because it's so damn stable. It's just going to keep going on forever. But with that, one of the things I wanted to touch on is the threads proposal in WebAssembly. So WebAssembly threads are a phase 3 proposal. That means they're still being implemented everywhere. And so a lot of people feel, oh man, I can't do concurrency today in WebAssembly. Now, many folks, ourselves included, we're able to run lots and lots of WebAssembly modules at the same time, so it doesn't really matter to us so much that we don't have threads, but there's a lot of workloads that people would really benefit from having some type of concurrency. I'm not saying that process spawning is going to solve all of your woes when it comes to threads, but it's a great way to get started. And you can do this today in Lunatic right now. So, what does Hello World in Lunatic look like? This probably looks pretty familiar. Y'all are all certified grain developers, 10 years of experience. It looks just like this. Any language that compiles to Wasm works on Lunatic out of the box. There's nothing special that you have to do. Of course, you're going to want to bind to some host runtimes and whatnot, but this just works. You run this with Lunatic, not a problem. But, of course, we want to set some things up so that way we can get some magic going. So in this case, we have the Lunatic SDK. We include that. We're going to spawn some processes, so we've got to bring that in as well. We want to have a main function. This is going to be the entry point of all the computation that's happening with Lunatic. It has to be called _start. I didn't have to use this special attribute here to do that, but I really wanted to call it main, so that's sort of just what happened. And last but not least, line 11, the Lunatic Bootstrap. This is provided by the library, and it makes all the fancy process stuff happen and be super cool. And I'm excited to show you that in just a moment. So, what does spawning a process look like? Well, from our main thread here, we say, hey, we're the main process. We're going to spawn a child. We do that by just calling process.spawn, and we pass a function. That's freaking fantastic. That's it. We did it. We have 2 processes running. And we didn't have to put any extra work. There was nothing to think about here. It just happened. And you can start to see how this becomes a very powerful concept, right? Because now, if I can spawn as many of these as I like, I can send work off to many different places at one time and not have to worry about it, right? Now, this is super cool, especially if you're a compiler nerd or a language nerd. You'll probably appreciate this. We need a way to get data in and out of processes, so back and forth. And there's a major way that Lunatic has to support this. But one of the things that we do with the grain library is we actually marshal your closures. So when you spawn a new process where you've closed over some other data, that data is already there and available in the other process. So here, line 6, we've got a record and some data. It's got a key, which is a string, a value that can be anything. And here, we create that local data on line 13. So it's going to get closed over by this function that we have starting on line 15. That's going to run another process, and it's going to print this data. That's it. We didn't do anything special to make this happen. It's just magic and works. So this is fantastic. This is powerful. If you want to spawn a process and just say, hey, here's some data, go run some MapReduce thing, you're done. That's it. You don't need to do anything special. But of course, you're probably going to have more messages than just what you have when you create that function. So you've got mail. We do this using mailboxes. And so now we're going to start looking at some code. I'm going to show you all how these work. So here, we've brought in the result type as well. And we create a mailbox. We're going to send messages on this mailbox. And when we want to process to get that data, we're going to receive messages on that mailbox. So here, we spawn a process. It's sitting, waiting to receive a message. And we'll come back to that in just a second. And we get a child. And this child is ready to go. Down here on line 24, we send to this child, hey, here's a lovely letter. Hope you read it. And we do it using that mailbox. So now, back in our function that's running in another process, we can receive data on this mailbox. If that works out, it's OK. We've got some mail. And say, hey, I've got mail, and this is going to print, hey, this is a lovely letter. Now, what's pretty neat about using Grain is we try to keep you from messing this up. Because you can probably see, oh, well, if I have a mailbox, I send some data on it. What if I accidentally send the wrong data? My function's not expecting that. How does this work? Well, conveniently, with types, I can say, let's send something else. Let's send a number. And then I get a type error. I get a type error that says, hey, this thing takes a string, but you give it a number. So we're also getting that support from the Grain compiler that's saying, hey, don't screw this up. We really want our processes to work. So that is pretty sweet. So let's talk about a full application. We're going to write a Telnet chat server. Now, this is a complete rip of the REST version of the Lunatic Telnet chat server, but it's pretty cool. And this one's in Grain, so it's, in my opinion, a little bit easier to understand and follow the code. We're going to need a lot of stuff to get this done. We need multiple processes, we need networking, and we're going to need some other fun things. So let's go ahead and get into that. So here, this is our main process for the chat server. What it does is we get Lunatic in here. There's a client and a coordinator, but we'll talk about those in a second. We load up some config. That's cool. And we start the coordinator process. The coordinator's job is to coordinate all of the processes that are going on. So all of the clients that are connected to the server, it manages those. All of the channels that people are chatting in, it manages those. It manages absolutely everything. Very important that it's there and stays alive. So from this main thread, we need a TCP listener. We got to listen for incoming connections and be able to respond to them. So we do that here. So just from lunatic.net.tcp.bind, we bind to localhost. The server started. And now we've just got a while loop that's going to run forever. It's going to sit there and just accept connections. The job of this process is only to accept connections and nothing else. Why? Because we can spawn more processes to do anything else. This thing can just sit here and accept connections. And so that's what it does. So as soon as it's accepted a connection, we say, OK, now I've got a TCP stream. And then once we've got that TCP stream, we're going to start up that process for the client. And so we do that right here. And then in Lunatic, one thing that's pretty important is resources are not shared between processes. So this is an important detail. So we need to officially hand off that TCP stream to the other process. So we do that by, as soon as this process spawns, we take control of the TCP stream. And then we've got a brand new client that gets instantiated. And then from this process, we go ahead and transfer that TCP stream to the child process. I'm sorry? All right. So that's how this all works. So we're going to now take a look at the client and see what the client does on this new process. So I'm going to come down here, and here we've got new client, and it accepts a stream. And so it says, hey, I need someone to manage me. I'm out here all alone by myself. And so here we go, and we got the coordinator. So now we have a reference to the coordinator. We can use that. Who am I? I'm this client. So let me ask the coordinator, hey, do you know who I am? And thankfully it does. So we get that information. And now this client officially joins the server. So it says, hey, I'm here. Know about me. Send me messages when people send them. Now, here's the fun thing about Telnet. It's a whole ass protocol. It's a whole thing. Now, we could have this client thread process all of those Telnet messages. We really could. But the client has another job to do. When those messages come in, it's got to render all the messages in a channel. So it's already got a big job. So let's go ahead and spawn a process just to do the Telnet stuff. So here, we go ahead and we transfer the stream over to the Telnet process and say, hey, this is your job now. You figure out what's going on with Telnet. We set some stuff on the Telnet. And then whenever messages come in from Telnet, we get these nice types. So I'm going to show you those as well. So Telnet is right here. So we've got a Telnet record here. It's got a TCP stream. It knows where we're at in the stream, some buffers. And then we've got this nicely typed enum of Telnet messages. So we have these commands that come in. We can say, hey, we're going to negotiate about the size of the terminal. That's NAS. The user types a character. We've got that. Of course, they want to delete stuff, enter commands, all sort of that fun stuff. But we get these the job of this process is just to get these higher level messages and send them back to the main client process so that way it's able to process that super efficiently, which is pretty sweet. And here's, we've got, constants and things to make that happen. And then, of course, I'm not going to bore anyone by going over, hey, what does Telnet look like? Oh, I will do this. oh, I won't do this. It's, it's a mess. But that's that. So we've got another process that's handling just the telnet stuff. And so another question you might have here is like, oh, well, what is the performance of Grain like? Well, I said, we're not trying to be Rust. We're not trying to be the fastest language out there. Like, we're trying to be good. Like, we're WebAssembly, right? We're trying to be good, but Grain is nice on weekends. Like, understand, right? So one of the beautiful things about Lunatic is I get more performance out of this, right? If my main client process isn't dealing with the TCP stream coming in, then it's free to just focus on UI stuff. And so you actually get a lot of process thinking about these things running in parallel like this. So that is our client here. Let's go on over to a channel. So channels, as you expect, this is where messages are going to all come together. So when someone sends a message, it gets broadcasted to the channel. All clients that are connected get that message. Coming into here, we have a bunch of functions to say, hey, someone's joining the channel, which is literally, hey, I have a collection of clients. Let me add it to the set. Someone's leaving the channel. Let me remove it from the set. And of course, when you connect, people have probably been chatting. You want to see what those last messages are, so it holds on to that. And most importantly, we've got these action mailboxes. So this is where the action things actually happen. And I'm going to show you the pattern that we use for that in here. So we create an enum, say, hey, someone wants to join, someone wants to leave, send a message, whatever. When a channel gets created, it's just going to sit there and listen for messages. That's all it needs to do. And say, hey, cool, this message is coming in. I need to do something with it. If someone wants to join, we're going to do that. Someone wants to leave, handle that. Someone wants the last messages of the channel, we're going to handle that. But of course, we actually have to talk between these two processes. So let's take a look at how that's done. And if we come down here, these are functions that are here to be called by individual clients. So this part might take a little bit to wrap your head around. But these functions get called in the process that the clients are running. So this process.send here, that's happening from the client process, sending it to this process. Now, when we want to get some data back out of that, like the last messages, we send that data off to the channel process, and then we immediately receive data back in the client process. And so this is a cool pattern because you can have everything here. You don't have to manage, hey, I'm over here in this process. Is this the time that I'm getting the message? Because I know I'm going to get information about the last messages as soon as I ask for it, right? So I think this is pretty cool. And of course, doing things like sending messages, shutting down, sort of all that fun stuff. That's that. And then the last piece, of course, is rendering the UI. And so I had to write like 2 Grain libraries to do this, so congrats, community, you're welcome. But we actually have like a library to actually render a real UI in the terminal. And so that's what we do here. That's what happens when all of the messages are processed. So we go back to the client, and we have our process function here, which takes a telnet command. If you say, hey, I want to switch tabs, then we switch tabs, and we say, re-render the whole UI, backspace. Well, delete the character the user typed, render the UI, that sort of stuff. So this all gets handled pretty nicely here, just calling into these functions. And then here are commands. So, hey, I need help. That's a classic one. I want to change my name. I want to see all the channels. That's all stuff that we have going on here as well. So let's take it back over here. Here's an architecture overview. This is a complete rip, like I said, from the Rust version. But taking a look at this, we've got these telnet processes. They've got TCP streams coming in. They're processing that data, making it readily available. We got these nice types that we send over to the client process. It gets those. It processes them. That's great. It renders the UI. And then messages get sent to the channels. And of course, it's all coordinated by the coordinator process. The only thing that's not in the Grain version is this coordinator supervisor, which is actually low-key pretty important. That's the thing that's going to restart your coordinator if it dies. I just didn't implement that. I'm not an Erlang developer. But of course, that is something that you would definitely need here. So let's do a demo. Let's see, does this thing actually work? So we're going to come over here. Conveniently, I've already compiled this. So I'm going to say Lunatic, and then it's called chat.wasm. And let's do it on port 4444. it gets started. And here I've got 2 terminal windows. By the way, Telnet not installed on machines anymore, so you do got to install that if you do want to use this. But let's connect. And so here we go. We get a welcome screen. It says, hey, welcome to Wasm.io. You're user 1, you know, good luck. And let's do that from another one as well. So that way we can have 2. This one happens to be user 2. So now let's change some names. Here I want to be Wasm Lord. I was Wasm Lord earlier today, and that turned out to be great, so we're going to keep doing that. And then over in the second one, let's just be Wasm Love. Wasm Love. And then we need a channel to talk in. We're going to do that with the join command. So /join general. So we're here. We also want this user to join the general chat. Before we do that, let's send a message, which is going to be hello. And Wasm Lord says hello. And so this one, we're also going to join general, or we can take a look and see what channels are active. There's general. It's got 1 person in it. Let's join it. So join #general. And we see Wasm Lord's message here. And we can be like, yo, Wasm Lord, what's good? And then we see, hey, Wasm Love is talking to us. And be like, go away. I'm not happy with you. Like, why do we both have Wasm names? That's cringe. But this is a full system that's running end to end. It's all written in Grain, which is sweet. So, of course, for people wondering, like, hey, what is the state of Grain? Can I write real applications in it? The answer is absolutely. You can absolutely write real applications like this, especially with the power of runtimes like Lunatic that give us all this great stuff for free, right? I don't have to do anything other than bind to it. And then when we get to component model, it's going to be even better. So, coming back, I want to say thank you to all of you for listening. This has been a lot of fun to get together. If you haven't checked out Grain, please check out Grain. It's super cool. If you haven't checked out Lunatic, go build stuff with it. Even if you don't want to use Grain. If you want to use Rust, you want to use assembly script, whatever, go check it out. It's a freaking amazing runtime, and I want to see more and more runtimes like this start to crop up. You know, if you've got an itch one day and you're like, I really feel like writing a freaking runtime today, do it. The community's going to love you for it. The community's going to thank you for it. And that's that. This has been great. Thank you so much. And I left time for questions. Let's go. I might redirect some of the Lunatic questions because the Lunatic folks are here. Say hi to them, wave. Yes. Sorry.
Oscar, that was a really cool talk, and it's really cool to see new programming languages emerge, especially in this particular space. My question is actually about Lunatic, though.
Yeah, let's do it.
So would it be a lot of work to add another language like TinyGo to that, and what exact benefits? It was a little hard to distinguish what parts were part of Grain and which were parts of Lunatic itself.
Yeah, absolutely. So when you look at bringing other languages to Lunatic, right now it is a manual process to write those bindings. But we've all heard so much about the component model, and it's going to be real easy to bring a language over. Even already, there's been a lot of work in Lunatic to make the API look a lot like component model. So basically, as soon as it's ready, Lunatic's going to be ready with component model. You're going to be able to say, like you're going to go to the Lunatic process. There's going to be a WIT file for you that says, hey, this is what you need. You're going to be able to spit that out, and you're going to start writing with TinyGo. And the benefits of using TinyGo, if it's a language that you're comfortable with, amazing. You're going to be super productive super quick. Maybe you're writing an application that needs even far more performance than Grain. You can use TinyGo, right? So depending on your use case, there's so much opportunity for so much cool stuff to happen in this space. Yeah. Who else? Yeah.
Thanks for the talk. It was great. To copycat Ralph, I would like to ask, like, what's the worst part of Lunatic? What did you hate about it?
The worst part about Lunatic? Honestly, the API is pretty good, especially from someone who wrote bindings to the Lunatic API. It's overall pretty good. I found that a lot of stuff that I expected to just worked. So I was super worried. I wrote the bindings for TCP, and I was like, yeah, I don't know if this talk is going to happen. But conveniently, it just worked. It worked the first time. I wrote the stuff for DNS resolution. That worked the first time. I was like, all right, Lunatic, I see you. This is like a real runtime. I could actually see myself writing this thing and deploying this to production, right? Because I'm pretty confident that it's going to work, especially with the fault tolerance of, hey, if this process dies, and I didn't even get into linking processes, making sure, hey, if these two processes are linked, they both die together, or spinning one of them back up. This is all stuff that's already available in Lunatic today. And so if something's going to die, you can program around it. You saw we had result types on everything. So you're going to know when something's going to break, and you're going to be able to fix it, which is super sweet. Doesn't really answer your question. I guess it was a lot of code for the DNS stuff, which was kind of annoying. Oh, actually, process spawning. That was kind of annoying because I had to do the magic stuff. That was more me than Lunatic. It's always me. Anyone else? All right, that's it. Thank you all so much. Please take care. I'll have all this code available for you later so you can take a look at it and play around.